Good afternoon, everyone. Welcome back to the session for Bachelor of Computer Application (BCA). Now, today we will be talking about
Are you
complex
healthy,
numbers.
dear teacher?
Sorry?
Are you healthy, dear teacher?
Yeah, I'm absolutely fine. Now, today, just starting from complex numbers. Till now, we have seen that we were talking about numbers only, and today we are listening some new word that is complex number. So what is complex? What actually complex number is, and why it is that so called? In the screen, you can see that there is. We are starting with I square equal to minus one, and I is equal to under root minus one. Till now, you have seen numbers with no sign, and if a number with no sign means it is a positive number. Now here you can see that in the under root it is minus one. Minus one means it is not a real number. And if we have to find its under root, then what we have to do? We multiply that number with minus 1 and take minus 1 in a single root and the number in the another root. You can see it. And now the question is what is exactly minus 1 under root? That is iota. Or we can say that I square is equal to minus 1. Now, a number is written in form of a plus ib. When a number is written in this form, that means a plus ib, where a is a real part and b is the imaginary part. B is the imaginary part. Why it is the imaginary part? Because it is having it is a coefficient of iota. Here you can see that what is under root minus a exactly means. It is equal to iota under root a. Now you can see various examples, exactly how it is solved and how we will be solving it further. Under root minus 25. Simply we can say that it is under root minus 1 into 25. Under root minus 1 is iota and under root 25 is 5. So that is why it is written 5 iota. Similarly, in the second example, it is not a perfect square of any number. So that is why it has been written like that. Iota under root 30. If we talk about under root minus 125, so minus 1, if it is in under root, straight away write iota. You are now remaining with under root 125. 125 can be written as 25 into 5. 25 under root means 5. It will be reduced to 5 iota under root 5. Now, in example number 4, what is happening? Under root minus 3 into under root minus 3. It is iota square into under root 3 whole square. So it will be reduced to iota square is minus. Don't get confused that minus iota minus 1 into minus 1 will be plus 1. It's not like that. These are two different identities. So that is why we have written I square. I square means minus 1 into 3. That is minus 3. And in the fifth example, you can see under root minus 98 upon under root 49. Under root minus 98 can be written as minus, that is basically iota, under root 98 upon under root 49. 98 and 49 can be brought in a single under root. So that will be 98 by 49, which is 2. So you will be left with iota root 2. Is that clear? Okay. Now you can see x is equal to minus under root minus 25 under root. So it can be written as like this, taking square on both sides. X square is equal to minus 25. By square, only under root will be removed. Now do it, because you have to take under root on both sides. So it will become under root x square is equal to plus minus under root minus 25. Okay. So it will be reduced to plus minus iota under root 25. And under root 25 is 5. So that means the value of x will be equal to plus minus 5 iota. Here we get another example. X square plus 54 equal to 0. And you have to find the value of x. What we will be doing? We will be moving this 54 on the right hand side. So it will become minus 54. Now we have x square is equal to minus 54. We have to find the value of x. So by next step, we can write it x is equal to plus minus under root minus 54. Minus 1 is minus under root is there, so you will straight away write iota. So it will be reduced to plus minus iota root 54. Now you have to split 54 in such a form that you get a multiple who has a perfect square of it. So you will get 9 into 6. 9 6 is 54. So under root 9 can be reduced as 3. And under root 6 will remain as it is. So you will get plus minus 3 iota root 6. So that means your solution set is plus minus 3 iota under root 6. I hope everyone is having pen and pencil, paper and pen with you. Because this can only be understood if you write it simultaneously with me. Because I'm telling you the steps, what are the steps, what you have to follow. And if you will be writing, so it will be easier for you to memorize it. Now see how multiplication is done with complex numbers. Because today we will be talking only about complex numbers, various operations, various properties, and their application. You have now multiplication minus under root 8 into minus under root 8. So we have seen an example earlier also that was of 3. Now what will happen? Minus, and when you will be removing minus 1 under root, you will get iota. And in the second one, you will again get iota under root 8. So it will become I square under root 8 whole square. Iota square is minus 1. You will get minus 1 by under root and square. Under root will be removed. So you will be left with 8. That is minus 1. Minus 1 into 8 is minus 8. In the second example, we are talking about division. So you can see that a number, complex number, a number is in the form of p by q. So your under root minus 56 can be written as iota under root 56 as usual, and in the denominator it will remain as under root 8. Now we will bring these two numbers in a single square root. So it will become iota under root 56 by 8. Iota. So 56 can be reduced, 56 by 8 can be reduced at 7. So we get iota under root 7. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Okay. Now we will talk about addition and subtraction. Here you can see that there are two numbers, A plus IB and C plus ID. We have to add two complex numbers. So keep one thing in mind. Like terms are added with like terms only. That means real part will be added to real part and imaginary part will be added to imaginary part. We cannot do that. Once we can add real part to the imaginary part of the another number, and the real part and the imaginary part of the other number. It's not like that. When you are adding two complex numbers, whether adding or subtracting, you have to add and subtract the real part in first step and imaginary part in the second step. You can see the two examples are given over here. 4 minus 6 iota plus minus 3 plus 7 iota. So what we will be doing? Technically we have to add 4 and 3, but 3 is having minus sign, so it will be separate. It will become 4 minus 3, that is 1. And when we talk about the imaginary part, it is minus 6 plus 7 iota. So it will become only iota. So your answer will be 1 plus iota. And if we talk about subtraction, so there are two ways of doing it. One is depicted over here, that subtract real part to the real part. 10 minus 5 is 5. And now we have minus 4. And this minus and this minus. This minus and this minus will get plus. So you will be having minus 4 plus 2. That will be minus 2 iota. Okay. Real part will be added or subtracted to the real part, and imaginary part will be added or subtracted to the imaginary part. Now, if we talk about multiplication, again the two numbers are there, A plus iota B plus and C into ID. So we have to multiply. What we do? We multiply first bracket with second. So straight away what we do? We multiply this A with C and A with DI. So we will get ADI. Second, B into CI, BCI plus BDI square. BDI square is minus 1. So you will be left with BD. That is minus BD. You can see over. This is AC minus BD plus iota has been taken common and you are left with AD plus B. Again, when you are multiplying a number, two complex numbers, you may get a complex number, you may get only an imaginary part, you may get only a real part. We have to keep in mind that no doubt when we are multiplying, and for multiplying you will be getting I square. So I square will be straight away transformed to minus 1. Now see, I want any one of you to explain me how this has been done.
Can I explain, sir?
Yeah,
Okay.
continue.
In the first example, we'd have 2 minus 4i into 3 plus 5i. And the first, we will multiply 2 with the 3, 2 by 3 plus 2 by 5i. Uh, then we will multiply minus 4i with 3. Minus with plus will become minus 4 with 5 I with I. And in the end, 2 by 3 will become 6. 2 by 5 will become 10. And minus 4 with 3 will become 12i. And minus 4 with I will become I square. And 6 plus minus 10 minus 12 plus minus 10 will become minus 2 minus 20 into I square will be I square will become minus 1, and 6 minus 2 6 we have 6 minus with minus will become plus 20. 20 with 6 will become 26 minus 2i, and the answer is 26 minus 2i.
Thank you. So nice of you.
Thanks, sir.
Any one of you who can tell me what has been done in example number 2?
So example 2 7 plus 3i square. It's in the form of a plus b square. It's equal to a square plus 2ab plus b square. A is 7. 7 square plus 2 into 7 is 7 into 3i plus b is 3i square. 7 square equal to 49 plus 2 into 7 into 3i equal to 42i plus 3i equal 3i square equal to 9i square. It will turn to 49 plus 42i plus 9. Instead I square we can write minus 1, and it will become 49 minus 9 become 50 plus 42i.
Very good. I just want to know remaining of my learners that anyone has doubt in it what she has explained. If anyone has doubt in it, just raise your hand and ask me what your problem is.
There is no doubt, sir. All of us know.
Okay. All of you know it. Okay, that's great.
Yes, sir.
Okay, we will continue. Now see what is happening over here. If anyone has any doubt in remembering this or understanding this, please let me know. Because I don't know while you will be solving it what power of I you will be getting. But you have to remember that I square is equal to minus 1. Now question arises, if any one of you have doubt about how we got it this value.
I don't have any problem in here, sir. It's just a circle of I, the power of I, and it has cycle from 1 up to 4. And after that, it will be written from 1, 2, 3, and 4. It changes from 1 up to 4, and after that, it will be written from the 1 up to 4.
You can see over here that you are having iota as well as 1. Now the thing is how to remember it. You know that I square is equal to minus 1. So I4 will be plus 1. Right? I5 will be iota only. I6 will be minus 1. I7 will be minus iota. This is basically something to the power. If you remember I square is equal to minus 1, you can convert it in any form, to the any power. Equality of two complex numbers. Two complex numbers are equal if and only if their real part is equal to the real part and an imaginary part is equal to the imaginary. Suppose we have two complex numbers, a plus bi and c plus di. If they are equal, that means z1 is equal to z2. If that is okay, so we can say that a plus bi is equal to c plus di. If that is okay, so that means a will be equal to c and b will be equal to d, leaving iota. In that case, we won't be considering iota. Or we can say that real part is equal to the real part and complex part is equal to the complex part of the second function. Now here is an example. 4x plus y equal to 12 minus 8y. You are being asked to calculate the value of x and y. Nothing to be worried about it. We can say that where is the iota in this? Okay, here it is. 3x will be equal to 12 and 4 will be equal to minus 8. Don't forget to take the minus 8, minus sign with 8. That is compulsory. So your answer will be 3x is equal to 12 and 4 equal to minus 8y. That means x will be equal to 4 and y will be equal to minus 2. In the second example, what is happening? Same thing is going to happen. Real part will be equal to real part and imaginary part will be equal to the imaginary part. What we are doing? 4a minus 3 is equal to 5 and your second part is 7 equal to 2b minus 1. So from first part we are going to get a as 2 and from the second we are getting a b equal to 4. This is what we have done, equating real part to the real part and imaginary part to the imaginary part. Now, to find
Sir,
the multiplicative, Aji? Yes, please.
sir, I think there is a mistake in the example one.
What happened?
4 is equal with the minus 8y. When we want to find the value of y, we will divide both of the equation to minus 8, and it will be minus 1 by 2, not minus 2.
Hmm. Absolutely correct. Y will be equal to, y will be equal to, okay, minus 1 by 2. Oh, I forgot to write it.
It's also have a problem in our chapter.
Sorry? What you say?
I said this problem is also in our book.
Okay, okay. Second part is okay?
Yes, the others are okay.
Now we will be talking about multiplicative inverse. Now see what has been done. This is the standard form what we have made it. We will be using the shortcut. This is actually what how it is made. But later on we will be explaining you to how it happens. Or it will be better if you know it right now because that will not be a confusion in your mind. Your problem is a plus ib, and I want multiplicative inverse of it. So what I will be doing, I will be writing it as 1 upon a plus iota b. Theoretically, in denominator, we don't have any complex part. So that means we have to rationalize it with a sign opposite to what we actually have. It will be 1 by a plus iota b into a minus iota b upon a minus iota b. So when you will be solving it, you will be getting this part, and when I will be taking this a square plus b square as the LCM. So in numerator, I will be getting a minus iota b. Now, moving further, we get conjugate and modulus of the complex number. Now the thing is that your number is z is equal to x plus iy. Its conjugate will be x minus iota y. Now remember one thing, we have to change the sign of complex part, that is the imaginary part. We will keep the same sign for the real part. In conjugate, only the sign of real part, only the part of imaginary part will be changed. If it is plus, it will become minus, and if it is minus, it will become plus. Now, the complex number will remain same, that is z is equal to x plus iota y. We have to calculate its modulus. So that is denoted by z mod. Two parallel lines, and in between we have z, which is equal to square root of x square plus y square. It will always be a number greater than 1. It doesn't make any effect, whatever your value is of the complex number, whether it is a minus iota b or a plus iota b. Your modulus will be a square plus b square whole, and it is denoted by mod of red. What you can see in the red. Now here it goes. We have to prove if x plus iota y is equal to under root a plus iota b upon c plus iota d, then x square plus y square is equal to under root a square plus b square divided by c square plus d square. What we are going to do? First of all, we will pick your if part. That is x plus iy equal to under root a plus ib upon c plus id. Now you can see to it, you have been asked to find the value of x square plus y square. So what you have to do? Pick the original question, square it. When you will be squaring it, under root will be removed. And in the left hand side you will get x plus iota y whole square. And in the right hand side you will be left with a plus iota b upon c plus id. Now the thing is that you can straight away take mod value it will become under root x square plus y square whole square equal to under root a square plus b square upon c square plus d square. With square under root on the right hand side will get cancelled. You will be left with under root x square plus y square whole square equal to under root a square plus b square upon c square plus d square. This is what was asked. Is that clear?
Yes, sir.
Now, representation of complex numbers on a graphic. First of all, we will be drawing a Cartesian plane. It will be having values from 0 to 10 on the x-axis and 0 to 10 on y-axis. Y-axis is basically a for imaginary part, and axis, the axis for real. So along x-axis we will be having x, and in the perpendicular form you will be having y, and the point OP will be the it is denoted by R, and the point P is actually x plus I1. Now, when we are talking about Cartesian representation, so we can write z is equal to x plus Iy, or z is equal to x, or we can write cos theta plus I sin theta into R. So when we will be opening it, or that means we can say that when we are comparing to real number, the complex numbers, so we will get x is equal to R cos theta, y is equal to R sin theta. Square them and add them. When you will be squaring these two equations, so you will be getting R square cos square theta plus R square sin square theta. Taking R square common, cos square theta plus sin square theta is 1. You will be left with R square is equal to x square plus y square, but you want the value of R. Your R will be equal to plus minus under root x square plus y square. Because I don't know how many of you are aware of trigonometry. Sin square theta plus cos square theta is 1. And when we will be dividing these two equations, r sin theta by r cos theta is equal to y by x. So we will be getting tan theta is equal to y by x. We have to remember that thing, x is not equal to 0. This expression, what I said, r into cos theta plus I sin theta, is called the trigonometric form or polar form of the complex number x plus I y. Now you can see find trigonometric notation for -1 minus iota. What we will be doing? Trigonometric notation means you have to write your answer in sin theta and cos theta and r. So we know that r is equal to under root a square plus b square. What is the value of a? A is -1. B is again -1. So this will become under root 2. Leave aside. Now move to sin theta. problem is to evaluate -1 minus iota. That means your A is -1 and B is -3. So your R will be under root A square plus B square. That will be A square plus B square. Your A is -1 and B is -1. This will become under root 2. Sin theta is equal to minus B upon A. B upon R. This will be -1 upon under root 2, which we don't have to keep under root in the denominator, so we will be rationalizing it. Once we will be rationalizing it, we will get root 2 by root 2. So it will become root 2 by 2 with minus sign. And in cos theta again, you have minus, so it will become -1 by root 2. Again, it will become minus root 2 by 2. Now, since both sine and cos are negative, and they are, its value is minus root 2 by 2. Since they are in fourth quadrant, so how you will find the value of it? Tan theta will be what? Y by x. Tan theta is y by x. What is y? This -1. You are left with 1. Since sine and cos both are negative, so your angle theta will be in the third quadrant. In third quadrant, x and after school 2, 10. Okay, sine and cos will be negative in third quadrant. So your basic angle will be pi by 4 and your complete angle will be 5 pi by 4. So that means we can say that -1 minus iota can be written as under root 2 into cos 5 pi by 4 plus cos cos, first is cos, second is sine. So that I sine 5 pi by 4. Or in short, you can write it root 2 cis 5 pi by 4. Is that clear now? Have you understood it? How it?
Yes, sir, it's clear for us.
Okay. Now we have to multiply these numbers. R1 is equal to cos theta 1 plus I sin theta 1. R2 is R cos 2 plus I sin 2. So when you will be multiplying it, what will be happening? It will be R1 and R2 will be the number, and that number will be multiplied by the trigonometric component. That means it will be a combination of real part and imaginary part. So it will be cos into theta 1 plus theta 2 plus iota sine theta 1 plus theta 2. Now please explain what has been done over here. Any one of you who can tell me what has been done? It is done by this method.
Third, this question is solved by the formula of this theorem, and R1 is multiplied with R2. R1 is 4, and R2 is 2. And 2 degrees. The first degree is 50, and the second one is 10. These 2 degrees will added cosine of 50 plus 10 plus I sine 50 plus 10. And after that 4 is multiplied with 2, it will be 8. And cosine 60 plus I sine 60, cosine 60 is 1 by 2 plus I sine 60 is square root of 3 by 2. Then we multiply the 8 by 1 by 2, it will be 4 plus I 4 square root of 3.
Okay. Now, are you aware of what is the value of cos 60?
Yes, sir, I know.
Anyone other than you is aware of what is the value of cos 60?
Sir, it's 1 by 2.
1 by 2. Okay. And sin
Just for
60?
cosine is this.
Sin 60.
Sir, it's 3 under root by 2.
3 under root by 2. Under root 3 by 2. Okay, what is the value of 1045? Value of 1045.
Square root of 2 by 2.
Square root by?
Square root of 2 by 2.
It will be how much? Okay,
this is
nothing.
similar to
1.
It is?
1.
Okay.
No, it's not 1. It's 1 for tangent. For cosine and sine is similar. It's 1 by square root of 2, or the square root of 2 by 2.
Okay. Okay. If I'm not wrong, you all are having pen and paper with you. I will tell you how to remember it. First, write 0. Adjacent to it, write 30. Then 45. Then 60. And then 90. Okay. And down
Okay,
it,
sir.
you write sign. Where you have written 0, write 0. Where you have written 30, write 1 by 2. Where you have written 45, below it write 1 by root 2. Where you have written 60, write root 3 by 2. And where you have written 90, below it write 1. Now you can see that sine 60 is 1 by 2. Sine 60 is, sine 30 is 1 by 2. Sine 60 is root 3 by 2. Sine 45 is 1 by root 2. And sine 90 is 1. Is that clear?
Yes, sir. It's clear.
Now for writing cos. Just reverse this order. For writing the value of cos, just reverse the value. Yeah, values. That means start from 1, cos 0 will be 1, cos 30 will be root 3 by 2, cos 45 will be 1 by root 2, cos 60 will be 1 by 2, and cos 90 will be 0. Is that clear? Now tell me, what will be the value of 10 for all these 5 values?
Sir, we can find 10. Sine by cosine will become tangent, and we can find them.
Correct. Now tell me, what will be the value of 1045?
1.
Where is that lady who was telling root 2 by 2? Now it is clear. I hope it's clear for all. This is exactly the method of remembering this. Now we're coming back to the problem. Now we have 8 into 1 by 2 plus iota root 3 by 2. Take 2 common, and you will be having 4 into 1 plus iota root 3, which is equal to 4 plus 4 iota root 3. Okay. Now comes your De Moivre's theorem. If R is equal to cos theta plus I sin theta, then you have to multiply. If you have any number in the power, what will be? It will be R into cos theta 1 plus I sin theta 1 raised to the power n. So this is nothing but this can be written as R raised to the power n into cos n theta plus I sin n. I don't understand Afghani. Please write in English. Or if you know Hindi, write in Hindi. Is this clear? This is De Moivre's theorem. Now, see what I've done. You have to use De Moivre's theorem to find root 3 plus iota power 3. First of all, what I will do, I will write root 3 plus iota is equal to r cos theta plus I sin theta. And then I will be equating real part with the real part and imaginary part with the imaginary part. So you can see over here that it is root 3 is equal to r cos theta and 1 is equal to r sin theta. Square both sides and add them up. Okay, so you will get 4 is equal to r square, r will be equal to 2. Now we have to find the value of tan theta. Tan theta is sin theta by cos theta. It will be 1 by root 3 because that is y by x. Your y is 1 and your x is root 3. Now going back to the trigonometric table, you can see that it is tan 30 is equal to 1 by root 3. Is that so or not? 10, 30 is equal to 1 by root 3. Is that correct or not?
It's correct, sir.
Okay. That means is this clear what I've done? I don't know. I don't know that this is an assignment or not. I have not seen your assignment as such till now. My basic purpose is to make you understand what the subject is. Is this
Sir, I
clear
have
to all?
solved the assignment. Yes, sir, it's
Sorry?
clear. I have solved the assignment question, and this is also a question of assignment. I just want to say for our classmates.
That's correct. But I told you that I have not seen your assignment as such. If it is there, so it's good. You can, if you have solved it, then it is good. You can see that whether you have done it correctly or not.
Yes, sir, it's correct.
It's clear to all. Okay. Now we have z is equal to 1 minus iota. And we have to find the value of z raised to the power 10. Now see to it how it is done. First of all, you have to find the value of mod z. Mod z will be equal to under root a square plus b square. Here, a is 1 and b is 1. That will be b is minus 1. That will be 1 square plus minus 1 whole square. That will be equal to under root 2. Okay. Now, what will be the value of argument z? Argument z is what? Y by x. Your y is minus 1 and your x is 1. It will be minus 1. Now the question arises, in which quadrant value of 10 will be minus 1 or minus? Are you aware of it? In which quadrant the value of the angle will be minus for tan theta? Which are those quadrants in which the value of angular value of 10 will be negative?
In the first quadrant, all of these, the sine, cosine, and all of these are positive.
Correct. What happens in the second?
And the second, for the second, sine and cosecant is positive, and the others are minus.
Okay. Third one.
For the third quadrant, tangent and cotangent is positive, and others are minus. And for fourth quadrant, cosine and secant are positive, and others are minus.
Very good. Now you can see over here we have a value of -1, and we have to find y by x is equal to -1. So in which quadrant we will be? You can see that your number is 1 minus iota. That is a plus ib or x plus iy. So x is on x-axis and y is on y-axis, but here it is in the negative direction. So it will be coming down. And your -1 will be in pi by 4. Value is 1. 10 pi by 4 is 1. But you want it as -1. So it will be minus pi by 4. Your argument will be minus pi by 4. Now the polar form will be, what will be the polar form? X plus z is equal to r into cos theta plus I sin theta. Your cos theta is minus pi by 4. So it will become cos minus pi by 4 plus I sin minus pi by 4. Whole will be multiplied by √2. Is this clear? Is this clear?
Yes, sir.
Now we have to find the value of z power 10 by de Moivre's theorem. Now see to it what has been done. R raised to the power n into cos theta plus I sin theta raised to the power n. Your n is 10. So it will become √2 power 10 into cos 10 minus pi by 4 plus I sin 10 into minus pi by 4. That will become 2 raised to the power 5 into cos minus 10 pi by 4 plus I sin minus 10 pi by 4. Reduce it. 2 raised to the power 5 is 32. This will become cos minus 5 pi by 2 plus I sin minus 5 pi by 2. See how it will be? transform. Cos minus 5 pi by 2 will be reduced to cos minus pi by 2, and similarly sin minus pi by 2 will be reduced to sin minus pi by 2. Sin minus pi by 2, sin 90 is minus 1. Cos 90 is 0. So it will be 0 plus iota. And sin minus theta is minus sin theta. So it will be minus iota. And 32 into minus iota will be minus 32 iota. Okay. Now we move to cube root of unity. Cube root of unity is similar to what we can write square root of unity. That means square root of unity means 1 power 1 by 2. And cube root of unity means 1 power 1 by 3. So we have x is equal to 1 power 1 by 3. So we will be doing cube of it. When we will be doing cube of it, so in the left hand side you will get x cube is equal to 1. That is x cube minus 1 is equal to 0. That is nothing but a cube minus b cube. So we can write it down as a minus b, x minus 1 into x squared plus x plus 1 is equal to 0. That means either x minus 1 is equal to 0 or x squared plus x plus 1 is equal to 0. Now the thing is that x is equal to 1 is clear, but it is not possible to break the power, x, middle term of quadratic part. So we will be using the formula. What is the formula? Minus b plus minus under root b square minus 4ac upon 2a. We will be applying over here. Now you can see that it is minus 1 plus minus under root minus 3. This under root minus 3 can be written as iota root 3. That means your value of x will be equal to minus 1 plus minus iota root 3 by 2. The three values of x will be 1, minus 1 by 2 plus iota root 3 by 2. And the third one will be minus 1 by 2 minus iota root 3 by 2. These are the key roots of cube. Because in this we are going to get under root negative 3. We can write it as cube root of unity as this 1 comma omega square, and omega cube is equal to 1. Remember this omega cube equal to 1, and 1 plus omega square is equal to 0. Omega cube equal to 1. So omega square is nothing but 1 upon omega, and your omega, this is all by transformation. Omega will be equal to 1 by omega square. So it is basically up to your requirement and feasibility how and when and where to use these values. Now, you will see it is given to us that 1 omega square as the cube root of unity. Then we have to show that 1 plus omega square minus 1 plus omega cube plus omega square is equal to 3. Now when you get this type of problem, try to convert We have different formulas. You have value of omega cube. You have relation between 1 plus omega square is equal to 0. Your omega cube equal to 1. So the thing is that after going through the problem, we have to change it accordingly. Now we can see in the first bracket it is 1 plus omega. We can't do anything. We can only convert this into in terms of omega cube. So if you remember what is uh, either to convert it in omega cube or with omega square. So we know that 1 plus omega square is equal to 0. We have 1 plus omega, so we can write it as minus omega square. In the next one, we have 1 plus omega square, so we can write minus omega whole cube. And in the third one, we have omega square, don't do anything, leave it like that. When you will be opening this part, you will be getting omega power 4, because minus to the power 2 is plus 1. This is omega 4, this is omega cube with plus sign, and this is omega square. Now take omega common. When you took converted this omega 4 into omega cube into omega, so that is omega. 1 omega cube is 1, and omega square will remain as it is. So it will become 1 plus omega square, which is nothing but equal to 0. What was asked to you to prove that this is equal to 0. I have used both the values, both the fundamental concept, that is omega cube equal to 0, omega cube equal to 1, and 1 plus omega square is equal to. Now this is the second one. 2 minus omega into 2 minus omega square into 2 minus omega 10 into 2 minus omega 11. Simple is that. Convert, bring it to the lowest form. Convert omega 10 and omega 11 in terms of omega. Omega cube into 3 is omega 9. And omega 9 into omega is omega power 10. So that means this omega power 10 will be reduced to omega. And omega power 12 will be converted to omega 11. That is omega 9 into omega 2, which will be omega 2. Now your question reduces to 2 minus omega into 2 minus omega square into 2 minus omega and into 2 minus omega square. You can see it is basically a square. So you can write it 2 minus omega into 2 minus omega whole square raised to the power 2. Now open the brackets and see what is happening. 2 into 2, 4. And this the 2 into minus 2 omega square minus 2 omega square minus 2 omega plus omega 3. Omega 3 is 1. 4, you can't do anything with 4. From this 2, minus 2 omega minus 2 omega square. Take 2 common. Then you are left with omega plus omega square. This is omega plus omega square is minus 1. So you are left with what? 4 plus 2 plus 1 whole power 2. That is 2 plus 4 plus 2 plus 1. 4 plus 2, 6, 6 plus 1, 7. So 7 square is equal to 40. This is what you are supposed to do. Clear? Now something colorful. See to it what is happening over here. If x is equal to a plus b, y is equal to a plus b omega square, and z is equal to a omega square plus b omega, then find and then show that x plus y, x, y, z is equal to a cube plus b cube. Okay, you take x plus x, y, z. We have to prove that what I will be doing, I will be just replacing the value of x, y, z in the left hand side. So in place of x, I will be writing a plus b. With y, I will be writing a omega plus b omega square. And with z, I will be writing a omega square plus b omega. Okay. I won't be touching a plus b. Because why? Why I'm not touching a plus b? Because in my answer, I don't want anything with omega, number one. And number two, we have to remove or we have to simplify simplify omega, because we know that omega cube is equal to 1 and 1 plus omega square is equal to 0. So see to it what I've done. I've opened up the bracket. Don't touch a plus b. It will be as it is, because in the right hand side we don't have anything with imaginary part. So that means we won't be touching a plus b. A plus b will be left as it is. And we will be multiplying the brackets. When we will be multiplying the brackets, a omega will be multiplied by a omega square, which will become a square omega cube plus ab omega square plus ab omega power 4 plus b square omega cube. Omega cube is 1, replace it. Okay. Now this is all simplification. Omega cube can be written as omega. Omega cube can be written as omega, then we can solve it. Is this clear?
Yes, sir.
Yes, sir, it's clear, but I have a question.
Yeah.
In here, where is omega square plus omega? AB into omega square plus omega. What is the value of
Just tell me.
omega square plus omega? Is this one?
I will tell you what has been done. This, just a minute, just a minute. Now see what I've done. I told you. Yeah. Now what I did, this is omega 4. Omega 4 can be written as omega cube into omega. Omega cube is omega. Omega cube is 1. What we are left with? AB omega.
Mm-hmm.
I've taken this AB common. So I've left with this omega square, this one, and omega from this. And omega square, 1 plus omega square is equal to 0. So omega square plus omega will be equal to -1. This is what I've written.
Okay, thank you, sir. Now I know.
And this is your standard formula. A cube plus B cube is equal to A plus B into A square minus AB plus B square. Now this is another question. 1 minus omega plus omega square power 5 plus 1 plus omega minus omega square power 5 is equal to 32. You have to prove it. Now, any one of you who can tell me what I've done? Anyone of you who can tell me what I've done? This is your problem, and here is the solution. Just let me know what I've done and why I have done and how I have done. The problem was given in terms of omega, and your answer is a real number. Am I audible?
Yes, sir. Sir, in this
That means
question,
everybody is thinking of what I'm.
in this question, 1
What
minus omega plus omega square by power 5. In this question, we can write 1 plus omega square equal to omega minus omega power 5 plus 1 plus omega square equal to 0. 1 plus omega equal to minus omega square minus omega square by power 5 minus omega minus omega equal to minus 2 omega by power 5 plus minus omega square minus omega square is equal minus 2 omega square but by power 5, and we can write it in this form: minus 2 by power 5 and omega by power 5 plus minus 2 by power 5 and omega square by power 5 minus between them minus 2 by power 5 is common, and minus omega by power 5 plus omega by power 10, because 2 into 5 equal to 10, and minus 2 by power 5 equal to minus we can change minus 5 into minus 5, no, omega 5, we can change omega 5 to omega 3 into omega 2. Omega 3 equal to 1, and 1 into omega 2 is omega 2 plus omega 10. And last question, we change that omega 10 is equal to omega, and minus 2 by power 5 is equal to minus 32, because minus 32 because minus by power 5 is equal to minus, not plus. And we have 1 plus omega plus omega 2 equal to 0, and omega plus omega square equal to minus 1. Minus 1 into minus 32 equal to 32.
Excellent. Anyone has doubt in it, what she has explained? Or should I explain it once again? Okay, I hope everyone has understood it. This is what transformation is. Now see what is happening over here. You are given that x is equal to a plus b, and y is equal to a omega plus b omega square, and z equal to a omega square plus b omega. What we have done, so we have done the other thing. Now I've picked up a problem, x square plus y square plus z square. Okay? So what I will be doing, I will be replacing x by a plus b whole square. A minus b or a plus b? It's a plus b. Okay, and I will be replacing y with a omega plus b omega square, and z with a omega square plus b omega. We will be opening up the brackets. So a plus b, a minus b whole, a plus b whole square is a square plus b square plus 2ab. First bracket is solved. In second bracket, again we will be squaring a square omega. I'm just telling you the answer. A square omega square plus b square omega 4 plus 2ab omega power 3. And in the third one, it will be a square omega 4 plus b square omega square plus 2ab omega 3. Now we know that omega 4 can be written as omega, and omega cube can be written as 1. Is that clear? Now what we will be doing, I will be taking a square common, and whatever is left with it, it will be 1 plus omega square plus omega square. Omega square nahi hoga, omega hoga. Plus b square into 1 plus omega 4 plus omega square plus 2ab into 1 plus omega cube plus omega cube. Omega cube is 1. Omega power 4 is omega, and 1 plus omega square is equal to 0. So we will be replacing 1 plus omega square plus omega with 0. In the second bracket again we will be getting 1 plus omega square, that is again 0, plus 2ab. We will get omega cube as 1. So 1 plus 1 plus 1 is equal to 3. 3 into 2ab is 6ab. Thus a square and b square will be 0. Is this clear? Somewhat tedious. I want that you should solve it, because I have skipped one step in between.
Yes, sir, it's clear.
Clear?
Yes.
Now what is this? X plus iy power 1 by 3 is equal to a plus ib. Then you have to prove that x by a plus y by b is equal to 4 times a square minus b square. Whenever we get this type of problem, so first of all reduce that power 1 by 3. This can be done by cubing it. So when we will be cubing both sides, we will be that 3 by 3 power will be 1. So we will be having x plus iy is equal to a plus ib power 3. Okay. So in that case, what we will be doing? We will be opening a plus ib power 3. That is a cube plus b cube plus 3ab into a plus b. This is what has been done. You have a formula of a cube plus b cube. A plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. This is what has been done. We have to keep the solution in the form of a complex number. So that is why two brackets have been generated. A cube minus 3a square b plus iota times 3a square b minus b cube. Now what we will be doing? We will be comparing two sides. That means from the left hand side, the real part is x, and on the right hand side, the real part is a cube minus 3a square b, and your imaginary part is y is equal to 3a square b minus b cube. Now what we will be doing? I will be taking a common. So when I will be taking a common, so I will be having a square minus 3a, and this a will come over here. So this will be changed into x by a, and this will be changed into y by b. Then I will be adding x by a plus y by b because I want the answer in this form. So when I will be adding it, the right side will be added up. When right side will be added up, so it will become something like this, and it will be 4 times a square minus b square. Is this clear? What next? Okay. Now see, this is multiplicative inverse of 1 plus iota upon 1 minus iota. What we are supposed to do? If we are talking about multiplicative inverse, so we have to just reverse. This has been reversed. The question was 1 plus iota upon 1 minus iota. After simplifying the first step, we got 1 minus iota upon 1 plus iota. And as per the norms, in denominator, a complex number is not there. To remove that complex number, what we will be doing? We will be rationalizing it. If we will be rationalizing it, so we will be multiplying numerator and denominator with the opposite sign. In the denominator, we have 1 plus iota. That means now we will be multiplying with 1 minus iota. So it will be 1 minus iota upon 1 minus iota. So this will be transformed to 1 minus iota whole square divided by a plus b into a minus b, a square plus b square. So that is 1 plus 1 is 1 square. 2. 1 plus iota square minus 2 iota. So iota square is minus 1. So this will become minus 2 iota upon 2, which is equal to minus iota. That means multiplicative inverse of 1 plus iota upon 1 minus iota is minus iota. Now we have a problem something like this. 2 minus under root minus 25 upon 1 minus under root minus 16. Nothing to worry. What we will be doing? Replace minus sign from the under root. So it will become 2 minus under root the 5 iota is under root 25 will become 5 iota and 16 will become 4 iota. So this will be 2 minus 5 iota upon 1 minus 4 iota. Multiply and divide with a sign opposite what we have in the question. So this will become 2 minus 5 iota upon 1 minus 4 iota into 1 plus 4 iota upon 1 plus 4 iota. In the denominator, we will again get a square minus b square. So it will be 1 plus 16 iota, 1 minus 16 iota square. That will become 1 plus 16, which is 70. Now move to the numerator. So we will be multiplying with the two brackets. It will be 2 plus 8i minus 5i minus 20i square. So that will be reduced to your I square will be minus 1. Minus 1 into 20 will be 20. 20 plus 2 is 22. And minus 5 iota plus 8 iota will be 3 iota. So your numerator will look something like 22 plus 3 iota upon 17. We convert them into the complex form. So this can be written as 22 by 17 plus 3 by 17 iota. Okay. You have seen how denominator is rationalized. Okay. I hope this is what we have in complex number. Now you can ask me any question because we have almost completed 6 units. We have completed determinants, matrices 1, matrices 2, mathematical induction, sequence and series, and complex number. Do you have any problem or any question? Just let me know so that we can solve it. Because in our next session, we will be talking about equations and inequalities. So we will be completing algebra 1 and algebra 2.
Okay, sir. Thank you. We don't have any question.
Okay, so when we, if you don't have any query access, so we can conclude today's session. Okay. Thank you, everyone.
Thank you, sir, for me.